Hello. In this video, we review how to solve equations which have fractions in them, otherwise known as rational equations. Let's get started. So recall that to solve rational equations like 12 over x equals 6 over 2x plus 3, this would be called a rational equation. We would first need to find what we call the least common denominator. So the LCD in this example would be what? That's right, 2x. So we would say, okay, let's go ahead and find that LCD. So in this case, the LCD happens to be 2x. If we hadn't already seen that our denominators were factored, we would have first done that, but it was already done for us in this example. Once you've located your LCD, that's basically the magic bullet that you can multiply on both sides of the equation to what we call clear your fractions. Could you work with fractions? Yes, but if you can get rid of the denominators and work with linear or quadratic equations, that would make your life a lot easier. So that's what we do in step 3. We actually multiply both sides of the equation, meaning every term on both sides, by your least common denominator. What is the purpose? To kill my denominators. Let's do it. So if I multiply 2x on the left and 2x on the right, notice that on the right side I have two terms, so it'll be 2x times each of those terms. And originally the problem was 12 over x on the left, so 2x will be multiplied by that fraction. And on the other side of the equal sign, 2x gets multiplied by the first fraction, which was 6 over 2x, plus 2x again gets multiplied by the second term, which is a 3 here. What ends up happening, if you've done it correctly, if you truly multiplied both sides, every term on both sides, by your least common denominator, is your denominator should go away. So let's see if that is the case. 2x is really 2x over 1, so you could either multiply and get 24x over x, which reduces, or you could simply notice that the x's are on top and bottom, so since the factors are multiplied together, we can cancel through multiplication. Now I just have 2 next to 12, which is the same as 2 times 12, or 24. So we've now gotten rid of the denominator on the left side of this equation. And on the right side, similarly, we have 2x over 1 times 6 over 2x. Once again, you could multiply and get 12x on top and 2x on the bottom and then simplify, but it's faster to notice that 2x and 2x cancel on top and bottom, leaving you just with the numerator 6 over the denominator 1. 6 divided by 1 is just 6. Once again, no more denominators. For the last term, this is the term most students forget about, you still had to multiply every term by that LCD. So 3, even though it didn't have a denominator, will still get impacted by that multiplication. 2x times 3, of course, is 6x. So now look what we have. We've taken an equation which had a lot of fractions, that's called a rational equation, and we've multiplied both sides by the least common denominator so that the fractions are now gone. We have a simple, in this case, linear equation. So go ahead and pause the video and solve that linear equation if you haven't already done so. So you did hopefully move 6 to the other side. 24 minus 6 is 18. And then you'd have 6x equaling 18. When you divide both sides by whatever's touching x, which is 6 in this case, you should be getting that x is equal to 3. Now, we're at the step here where we've solved the equation, step 4 of this checkbox. The last thing you have to do, however, is make sure that your input that you just got for your answer x is a valid one, because there are some inputs which would be problematic for an equation involving fractions. For example, if x had been 0 as my solution here, would that have made sense given where x lives in the original equation? Well, no, because we'd have to then divide by 0. 12 divided by 0 would be undefined. Similarly, 6 would get divided by 2 times 0, and 6 divided by 0 is still undefined. So if x had been 0, I would have had to say, really, there's no solution. But in this case, x equals 3 is a valid option because it keeps the denominator non-zero. You can also check that it actually works. Does 12 divided by 3, here's my little check, does 12 divided by 3, which is in fact 4, equal the other side when I insert my input x to be 3? Well, that would be 6 over 2 times 3. Well, that's 6 over 6, which is 1. And 1 plus 3 is in fact 4. So yes, we have verified our answer is not only plausible, but it's also accurate. All right, so always check your solutions, rejecting any solution that makes denominators 0. Let's see if you can apply this to a little more complicated situation, but the same structure will be applied. Example 1 says, solve the rational equation if possible. On the left side of the equal sign, you see 6 over x squared plus 8x plus 15 minus another fraction, 2 over x plus 3 equals, on the other side of the equal sign, negative 4 over x plus 5. So to begin, see if you can pause the video, look at your notes, and try it yourself, and then see how you did. Okay, what did you do as your first step? Did you factor? Okay, let's see how that worked. When you factored your first denominator, what did we get for x squared plus 8x plus 15? One factor should be x plus 5. Another should be x plus 3, factors of 15 which add up to 8x when you FOIL. That makes sense, doesn't it? Notice to get my LCD, once I have everything factored, which it appears I do now, my LCD should account for every factor of the first denominator and then take on any new factors that I see as I move from left to right. If you forgot that, check back our last video on simplifying and combining rational expressions, okay? So the LCD in this case would be the entire first denominator of x plus 5 times x plus 3. And then I scan the problem from left to right, and I check whether or not I have another new factor. X plus 3 in the second expression is the same as we already have. X plus 5, we already have it. So there's nothing to add to our LCD. It is, in fact, just those two factors multiplied together. Now, could you FOIL it out? Yes, but for the sake of simplifying as we go, we're going to wait on that. So what's your next step after you've located your LCD? What were we trying to do? That's right, we wanted to get rid of all of the denominators. And what was the magic bullet that allows us to assassinate all of your fractions? Yeah, it was multiply every single term by that LCD. Let's do it. When you multiplied the first expression by the LCD, what happens? Feel free to write it out, but what will ultimately happen? I'll write it out for us this time. X plus 5 times x plus 3. Again, x plus 5 times x plus 3. And again, x plus 5 times x plus 3. The more you do these, the more practice you do, the better you're going to become, but also the faster you'll become. You'll start to see shortcuts like, oh, I can do that in my head. I don't have to write that down again because, look, I know that the entire denominator cancels with the LCD in the first case. So if you just said, I know that's going to be a 6, I'm not going to write it all down, more power to you. It's good to save time if you see it. In the second case, if I had negative 2 over x plus 3, what would cancel from my LCD when I multiply? The x plus 3, you're right. So all I should have left is that negative 2 next to the part that did not cancel of the LCD, which was x plus 5. On the other side of the equal sign now, I had negative 4 over x plus 5 originally. But when I multiplied it by the LCD, what cancels? The x plus 5 cancels. Well done. So you should still have the negative 4 next to the factor that did not cancel, which in this case was x plus 3. Now we have an equation with no more denominators. That's what we use the LCD to do when we are dealing with the rational equation, to eliminate all denominators. At this point, try to solve this equation. If you haven't already done so, pause the video, solve this linear equation just like you normally would. Okay, let's see how you did. Did you distribute correctly in both cases with your signs? Watch out, we often make mistakes here. That would have been negative 2x, and negative 2 times positive 5 is negative 10. So if you made a sign error, make a little note because we tend to repeat our mistakes. So when you're practicing, make sure you're not repeating the mistake over and over again because then you hardwire in your brain to always make that mistake, right? Similarly, negative 4 times x is just negative 4x, and negative 4 times positive 3 is negative 12. So watch those signs. To solve a linear equation, I hope you remembered how to do that. You got your x terms on one side of the equation. In this case, I'll choose to put my x terms on the left and my non-x terms on the right. So to do that, I noticed that I had negative 2x on the left, adding 4x, because when you change it to the other side, you're adding it, would become negative 2 plus 4, or positive 2. As a result, 2 copies of x on the left. On the right side, I could do it a couple of ways. I could just move over the 6 and the negative 10 by changing the signs right away, or I could combine them first, which I think would be wiser. 6 minus 10 combined is what? Negative 4. Now move it to the other side, it's a positive 4. So if you take a negative 12 and a positive 4, the result should be negative 8. Dividing both sides by whatever's touching your variable x, you would get that x should equal negative 8 over 2, or x must be negative 4. Now, before you call it a day and declare your victory over this problem, which is a great feeling, I know, check whether or not this answer is plausible, and if you have extra time, if it's actually accurate. So for plausibility, you look back at your factors in your denominator and make sure that when you input -4, it does not create a 0 in any denominators. For example, in the first case, those factors were x plus 5, x plus 3. If you notice that the only one that would make this 0 would be x plus 4, right? Because then -4 plus 4 would wipe out. Since I don't see an x plus 4 anywhere in any of my denominators, this is plausible. Then you could check if it actually is accurate by plugging it in and seeing that both sides are the same fraction. So if you have extra time, go ahead and do that. You can also click on the Desmos link provided on each of the slides in the notes online, and that'll show you the graph and show you exactly where these two graphs are equaling each other, and it should be right when x is -4. All right, so let's head over to another example and see if you're learning these skills and if you can become proficient at them on your own. Take a look at example 2. It says, could you solve this rational equation? 9 over x squared plus x minus 12 is supposed to equal 1 over x plus 4 minus 5 over x minus 3. All right, so pause the video, try it on your own. Okay, when you tried it on your own, the very first thing you do is factor, right? See what your denominators are in terms of factors. So what did x squared plus x minus 12 produce when you factored correctly? Did you get x plus 4, x minus 3 in either order? I hope so. Let's see why that makes sense. Because 4 times -3 produces a product of -12, and 4x minus 3x yields positive 1x when I FOIL. So that would be the correct interpretation for those factors. So far my LCD must contain those two factors, x plus 4, x minus 3. Are there any new factors as I move from left to right in the problem? No, there's the same x plus 4 and there's the same x minus 3. But notice if there was a new factor like x or x plus 3 or x minus 4, I'd have to tag that along and make my LCD bigger. In this case, it's pretty nice. What was the next step after you have found your LCD? What is the purpose of finding it when solving a rational equation? That's right, you're trying to eliminate your denominators. So did you multiply every single term on both sides of the equation by the LCD? If you did, the first case would cancel completely, wouldn't it? You would just have a 9 on the left. Feel free to write it out if you need to, but now I'm trying to save a little more time, which is hopefully what you're trying to do as well. The second expression, 1 over x plus 4, when multiplied by that LCD, x plus 4, x minus 3, who cancels? That's right, x plus 4, so who's left? 1 next to the factor that did not cancel, x minus 3. Similarly, -5 would be next to what after multiplying by the LCD? That's right, x minus 3 cancels, so the only factor that remains from the LCD is x plus 4. So now once again we have a linear equation. Now it could be quadratic or any degree equation really, but we're giving you nice ones right now just to get your feet wet, all right? Notice here I technically had to multiply by whatever was in front of the parentheses. I had to distribute, but if it's a 1, you know that what happens when you multiply by 1 is you get back to your original. So you end up just with 1x or x and -3. So x minus 3, that makes sense. Watch your signs here, -5x and -20, not positive 20, right? Equals 9. When you combine your x terms together, 1 copy of x minus 5 copies of x is -4x. Good job. Similarly, -3 and -20 are like terms, so now I add them together and they're both negative, so it becomes -23. And then finally, I want x by itself. I pick which side I'd like that to happen on. I'll move -4x to the other side and 9 to the right. So this becomes positive 4x on the left, and 9 is now negative, and -23 as well. So what does that produce for us? Well, we have 4x on the left, and what is -9 minus 23? They're both negative, so it stays negative, and that becomes what? -32. So they're being very nice with their numbers here. Divide both by 4. Your answer for x potentially, I say potentially, is that x equals -32 divided by 4. In other words, did you get -8 as a possible answer for x? Okay, now again, what this means is if there is a place where these two graphs are touching, it would be when x equals -8. but it's never a guarantee. Whenever you're solving a rational equation, you have to check if it's really plausible. So when would this not be plausible? If one of the factors was x plus 8, right? Because that would create negative 8 plus 8, a 0 in the denominator. Did you see any factors that were x plus 8 in the denominator? No, I didn't. So this is a plausible answer, and then I can check now if I have extra time, if it's accurate, if it's truly the answer, by multiplying and adding and doing all the arithmetic on both sides when x equals negative 8 and seeing if they get the same result. Okay. Also, the Desmos links are a great way to investigate to see what's going on behind the scenes. All right, so at this point, we have shown you 2 examples. You've practiced, you've seen me do it, and you've tried it yourself, hopefully. But now it's up to you to go make this your own. So go practice, because math is not a spectator sport. I'll see you next time.